Welcome everyone to the May 26th OMR Architecture Meeting. Today we have one topic to discuss, and it's issue 6508, which was initiated by a discussion on a defect that popped up on AR64, and Devin Papineau is agreed to take us through that discussion. So Devin, can I turn that over to you?
Okay. Oh no, I don't want to do video. That's not it. Can I share my screen here?
Absolutely.
As soon as you start sharing. Okay, share. And it will be this one, which has. Okay. Can everybody see that?
Yes.
All right. So this isn't. It's not super fleshed out in terms of opcode stuff because the opcode is very straightforward. This is more about the motivation for why I'm suggesting an opcode here. So this is long or int to GCref. So at the moment, we have a long and int to address, right? So here's our node, and it's got a child of integer, some integer type, and it's the integer value of an address, and then we convert it to an address type node. We have two kinds of addresses, right? They're the collected and non-collected ones. So it's basically, is this an object managed by the GC or not? And L2A, well, it's not clear what whether it should be collected, right? If this is the address of a GC object, then of course L2A needs to be collected. But if this is the address of something else, you know, a class or something, then it had better not be collected. If we look more closely at the collected case, where did we get this address, right? And the only way we could have gotten that address really is by taking the actual address type thing and then converting it to an integer. But when we do this, the GC doesn't know about this integer, right? It loses track of it. And so by the time we use it, we could end up with the object having been moved or having been freed while we were just holding onto this integer. There's nothing to keep it fresh. But we don't. There was this pull request a while back to stop converting references to integers. It confuses us about what's collectible and what's not, and you know, we just decided that there's no reliable way to do it really, and we don't need to make a reliable way either, right? For example, we had you know, Loop Strider used to generate this tree that looks kind of like this, right? So originally it would have been an integer comparison on the integer typed IV, but then it creates an address typed one, and then it would still do an integer comparison, but it would convert to integers. It would convert its address type things to integers to compare them. And I think so. Possible way that the problem could manifest here is, say, this A2L gets comment somewhere further up, and there's a GC point in between. Now you can have a problem, right? So we stopped doing that. It doesn't generate this, as of this pull request. It just generates an address comparison. And I think, anything where we were converting. Sorry?
No, let's just keep going. Go ahead, please.
Okay. And we have this compute is collected reference query that just says, well, if it's a conversion, then it better not be collected, right? Because if it's collected, we have a bug. So back to this question of which one is L2A, right? Here's this collected object case, and this is not allowed, really.
Sorry, Devin, can you go back to your previous slide for a sec? So that's a question that you ask on from your previous slide, the L2A node, or sorry, the A to L node?
It's a question that you can ask on, not on the A2L node. So this is the conversion to integer.
Yes.
As opposed to the conversion from integer, right? We are concerned with the conversion from integer to address. The thing is that the conversion from integer, if I come back here, here's our conversion from integer to address, right? And basically, it's in the GC managed case. It's only useful, or never mind the GC managed case. It's basically converting the integer to an address. Generally only makes sense when we have gotten that integer by converting an original address to an integer first. And that conversion from the address to the integer is what here, we sort of discovered that it's basically not meaningful.
So Devin, you showed a tree which used the A to L opcode. I can see sort of why that was being done, and now we may have an if A compare less than opcode, so I can see how it doesn't have to use an A to L maybe over there. So I guess I'm still unclear on where do you see L to A get used. So is it like if we are already using an if A compare less than, then there is no A to L in that tree. And if there's no A to L, then what are we putting under L to A?
So one of those is about to come up. I don't have much more in here, but the other kind is let's say we have let's say we were looking at some code that contains something that the compiler knows about. To give a J9 sort of example, it would be, this method handle has the address of a, let's say a J9 method in it, and it's a long, and we have to we load that out. It's long type, and then maybe some Java code loads it, and then it passes it to some intrinsic, and then the intrinsic says, oh, I know that this is really an address. So we do L2A, and that's fine because this is not the address of a collected object, right? It's not going to move or disappear on us just because our reference, like our integer, is unknown to the garbage collector.
Okay. Thanks.
Okay, so just going back to that slide that I asked the question on, can I just see that again? Yeah, this one.
Right.
So which node would you ask this question on then?
This would, so you can ask this. I don't know that it makes sense to ask it on any node. Although if it was not a reference typed node, I guess you could say false. I don't recall what it does in that case, if it asserts or, but it really only matters for reference type nodes, which is to distinguish between.
I guess what's confusing me on
between
that
these
slide
cases
what is being returned there? You've got ... tr no ... What's in the ...
Oh, that's just memoization.
Okay, so we're going to
So
say
it returns
no.
it returns this, but it does it via an intermediate function call that remembers the result for this node.
Okay.
Just to avoid a exponential walk.
Okay, all right. I just wanted to get that clear in my head. Okay, thanks.
Anyway, so this question, I suppose it could possibly be posed of the A2L, but it's not really very meaningful for that. It's the L2A. We say no, it's not collected, right? And we say that because if it were collected, we would have this case, right? And this is the case where we took the address of one of these things and we put it into an integer where the GC can't see it, and then now we don't know whether it's good anymore, right? So we say this is not cool, and don't do that. And so then it has to be, this should say non-collected. This is not a collected reference. All right, and that seems pretty straightforward, except for compressed refs lowering. So we lower the compressed refs. They, you do an integer typed load of, some field of some object that refers to another, GC managed object. And then we do some arithmetic on it and then convert to address, right? And the thing about this is that this is very much a collected reference. And what happens now is that this puts the cogen into a situation where it's sort of trying to guess whether this thing is collected or not. The discussion came about because the Slack discussion, this sort of that brought all this up, came about because there was some case or cases where it was guessing wrong, and so my suggestion was, let's have a way to just specify let's just be precise about whether this is a collected reference or not, right? And given, everything leading up to here, I would want to say this is non-collected. And then we'll add a new one, and this is L or I. It has exactly the same behavior, but the result is a collected reference. So that's sort of the problem statement and my brief suggestion for what to do about it.
The thinking that we may not need a GCRF to long opcode because there's no use really for it at the moment. So we just restrict ourselves to what is minimally required here. I assume this L2 GCRF would be used immediately in that compressed ref tree that you showed, right?
Right, that would change to be L2 GCRef or I2. Oh well, I guess we don't even necessarily need the I2 GCRef because compressed references isn't a thing on 32-bit, right? You would compress them to they're already 32-bit.
Yeah. So if you're only introducing basically that one opcode, right? L2 GCRef, which
right.
will be used in that scenario, the compressed ref.
Yes, and then everything else, anybody else who has an address that they know is good and want to convert it to an address type can use L2A or I2A, as the case may be. And then, Cogen will know that is not collected. And then the ones from the compressed refs lowering would get this, and Cogen would know that it is collected.
So the back-end implementation of that is really just to ensure that a collected reference register is allocated for
Yep.
the conversion.
Yes, and to make sure that a non-collected register is used for these other ones.
Are there any other means that we use to determine whether or not a node contains a collected? Like, have we done any other attempts over the years to look at these kind of conversion nodes and determine what it's really trying to do? I'm just wondering if any of those cases need to be undone if we now have a dedicated node that makes it very explicit.
Not to my knowledge. As far as I'm aware, basically these cases where we have, here's some integer that's been squirreled away in the source language that we're compiling, but we know that it's an address. I think those tend to be very short-lived. Not necessarily across a GC point.
Okay.
And I think if I recall from the discussion, the cogens seemed to treat the collectedness of L2A in a way that basically just assumes that it came from the compressed refs lowering whenever compressed refs is on. Right. So if your other uses of L2A happen not to cross GC points, then it doesn't matter what kind of register you've got. So I suspect that they've just been sneaking by
Yeah, I think there's very few, maybe even literally the ones that Devin showed, the one that Devin showed, where you have a collected reference and this sort of thing is going on. Otherwise, it doesn't matter, as you were saying. So in this case, if you allocate a non-collected register for the long value that is below L to GCRef, and you allocate a collected reference register or collected register for the L2 GCRef, even if the long value has a ref count of 1, does that imply some sort of reg move in the code gen, or will it just subsume it somehow?
I think it will need because there would be distinct registers, right?
Distinct virtual registers.
Distinct virtual registers.
But couldn't you do some sort of clobber evaluate or? But maybe you can't do that.
It can't be hard to subsume it, I don't think.
Sorry, can you repeat that, Devin?
Oh wait, never mind. I retract that.
It might be, even though the virtual registers have to be distinct, because
oh, no question about that. Yeah.
I'm wondering. I think the actual register assignment could recognize, like if both of those got allocated to the same register, because one died, like if the live range died, and you got it could eliminate that copy.
So that could be something to make sure.
Yeah, we could. I think that'll already happen. Like that's fine.
I think what I'll say about that point is that I don't think it's particularly related to whether or not we have this new opcode.
Yeah.
It's already the case that CodeGen will see L2A in this compressed refs case here. And if it ends up with a non-collected register, and then it necessarily has to treat this one as collected, or nothing is going to work. It's the same issue that it must occur today.
Yeah. Yeah, it's more a question of what is the behavior rather than, as you say, it's not an additional point arguing for or against L2GC. I think it's in my opinion, it's a cleaner change. It's a change in the right direction. It makes things cleaner and more explicit. Only because you mentioned it in the deck when I asked it. There was an earlier slide about is conversion. Is this new opcode considered a conversion?
So I guess it would be a conversion. So this code might need to be adjusted if this. I mean, ideally, we should probably adjust this code regardless of whether it's used in CodeGen after those L2 GCRef nodes might have been generated.
Okay, so this would be considered a conversion just as L2A is considered a conversion.
Right. It's just that it would only be introduced very late at a point where we have a handle on what might happen to with the conversions, so that we're not creating the kinds of problems where the kind of confusion that made us stop doing this in the optimizer, right? There's not nearly as much transformation going on at that point, and we can have an idea that And you know, we sort of already do have that idea that well, these things are going to be a collected reference. You know, it's the address is the result of this arithmetic, and it's just sort of knowing that we will not hold on to things in integer land behind the back of the GC for long enough that it becomes a problem, I guess, is the thing that we have to know. Right, so the opcode would just be explicitly distinguishing those two cases, right? It's we've generated you know, some round trip through integers that that we are hiding from the GC versus you know, L2A, which you can use at any time, but it had better not refer to GC things.
Okay.
Have you? This is again, there's no disagreement in the terms of the principle that you're of the proposal that you have, but just thought I'd ask: did you consider having the L2A as resulting in a collected reference instead, and an L2 not GCref or some other opcode like that? I don't know, like, if address or A represents a collected reference in most cases anyway, and so it's kind of a reason for maybe considering keeping L2A as the one that's collected and the other one is the exception to the rule. I don't have a strong preference myself. It's akin to a naming discussion, really, but I was wondering if, I mean, I thought I'd just mention it to see if there's any thoughts that get triggered from that.
I hadn't really considered that.
I think you only found the one case where the L2A is behaving on a, like in the compressed reference.
As a collected reference.
So there's one case of that, whereas L2A, I think, is used in more places, meaning that there's more of them.
Oh,
it's more common in the non-collected reference.
More common in the code base.
Yeah. Meaning that it, maybe L2A should apply to non-collected references, and this new one apply to collected references. Mark brought up a comment in the discussion, the original discussion, about whether or not we should have made a collected reference an actual type, which arguably would be a much bigger and more pervasive change for sure. I'm not sure that's needed in this particular, at this juncture. I don't think it's needed, but it's another area to noodle about, maybe.
Right.
So I think, I mean, at least between this Vijay and myself, we seem to be in favor of the of this particular proposal. I don't think, from an implementation point of view, I mean, yes, there will be some work needed on each backend, but that should be relatively minor. And in fact, some of that code might even be able to be shared. I mean, if you're just creating a new collected reference register and allowing it, well, then you need to do the moves as well. But anyway, it's minor work that needs to happen. And then there's probably a few places in the common code that need to learn about the new opcode and the semantics of it. So, but I don't think that that's overwhelming. So, does anybody have any objections or see any issues with what has been proposed other than what we've discussed? If not, I think that a pull request at some point should probably be in order. I don't think you necessarily have to do all the back-end work. You know, introducing the opcode could be one PR, and then we do the back-end work to implement it. That could be one thing we do.
Okay.
Bit of a lower priority task too. It's not the original problem. I think we were able to work around in on AR64, but okay. Any other discussion on this particular topic? Okay, I'll take that as a no. So, okay, thanks for taking us through this, Devin. I think it's a good bit of conceptual integrity that we've, like as we just said, is a bit long overdue here. So I'm glad we can do this going forward. Okay, that's all that we had on the agenda for this week. So thanks everyone for attending, and we'll talk again in a couple of weeks. Thanks. Bye.
Thank you.